Okay, so this worksheet is about exponential growth and exponential decay. We just watched the video where it was discussed with the real life problems, and now with these many problems on the board, we'll think about how the exponential functions can help us to predict the growth or decay in real life. If you remember, the general formula for the exponential functions that we had was something like y equals a times, and I'm intentionally using now the green color for a, and then 1 plus, I will use the purple color for r, and then I will use the red color for t. T is a time period. We have replaced the variable x here with the t. We have replaced the variable x here with the t. So what are these a, r, and t here? Let's see it. A is the initial value, and I will use the initial value. Remember, this session is being recorded. Whatever we are saying will be there in the recording. Any questions related to any other stuff, we can postpone that. Those questions for 10 minutes. Initial value. A is the initial value here. What's the R? Because this slide you see over here, it's showing us exponential growth. So for this specific side of the assignment, the exponential growth, I will call the R as the growth rate. And I'm using the purple color to mention the exponential growth or the growth rate. The growth rate. Growth rate. Why am I using these colors? I will tell you shortly. Then for the T, the time period, number of turns, number of years, number of months, whatever is mentioned as the repetition or the turns in your problem, real world problem, that's what we will mention as a T. So number of turns or the number of turns. So let's read the statement together and figure out what's the A, R, and T here in the word problems. But let me tell you and try to connect this whole statement or the function with the B from the original function of the exponential form. What was the exponential function? That was something like y equals, that was something like y equals a times b raised to power x. That's what we had initially. Now what I'm saying in the exponential growth, I'm claiming b is equal to 1 plus r. 1 plus r. So b is replaced with 1 plus r. Remember, on this function, y equals to b raised to power x. How did we determine if it's an exponential growth or an exponential decay? What was the determining factor? Which of these parts in this function told us if it's a growth or a decay? A, B, or X? B. B told us if it's an exponential growth or a decay. What was the criteria? What should be B for the function to be the exponential growth? Greater than 1 or less than 1? Greater than 1. If B is greater than 1, then the function, exponential function, will be an exponential growth. And if B is less than 1, then the exponential function will be an exponential decay. So that's why we have added here for the growth, we will add the R, or the percentage addition will be added. Now let's use the highlighter, read this statement. The original value of the investment, the original value of an investment is 1,400. Original value or the initial value, I will highlight it in red color. Okay? No, sorry, green color. I will highlight the initial value, principal value, original investments in green color because I'm trying to connect it with the A. And then the growth factor, how much is it growing? It's saying the investment and the value increases by 9%. So if it's increasing by 9%, so that's the growth rate. 9% is the growth rate each year. And what is the term? A year is a term here. Use the exponential growth function to find the value of the investment after 25 years. So you see, this 25 over here, I highlighted it in red color, is giving me the value of t. Let's substitute these three values in the function. How will I do that? Y equals initial value, that's the replacement of A. So Y equals 1,400 times 1 plus R. And what's the R? The growth rate, which is in 9% here. I can mention the 9% as a 9 over 100. And then whole raised to power T is replaced by its value, which is a 25. We have the value now. Let me show you how will you solve this thing using your calculator. In your calculator, let me bring it up here. Okay. In your calculator, we will start by typing in from the initial, like the screen, we had the 1,400 over there times 1,400 times, let's use the parentheses, and inside the parentheses, what I will do, 1 plus 9 over 100 or the 0.09 are the same things. I can put the 0.09 also over there, 0.09. And then outside the parentheses, I will bring in the value of t, which is using this at sign, the key or the exponent, raised to power what? 25. And then hit enter, and that tells you the value is going to be 12,072 in 25 years. So we can bring that result back over there in our worksheet. 12,072 point something. That's going to be the value of the investment in 25 years. Does that make sense? So only three things to determine: the initial value, the growth rate, and the number of terms will help you to solve any of these problems. What I will try to think about now, considering these things in mind, let's try to figure out the problem number 3. How will I do that? I will now just highlight the things over there. Let's read it together. And you will tell me what's the A, what's the B, not the B, R, and what's the T. So reading the problem number 3, the number of student athletes at a local high school is 300 and is increasing. Whenever it's saying increasing, that tells you that it's a growth function. Okay. If instead of increasing, it's saying decreasing, then that will be a decay, the growth, the exponential decay. Here, because it's increasing, so it is an exponential growth. What do you think is a 300? 300 is A, exactly, good, because that's the initial value. So 300, I'm highlighting it in green. We will replace the A with the 300. Increasing at a rate of 8%. So what's an 8 or what's an 8%? What's the 8% here? The growth rate Yes, and what are we using the letter for this? Here. Let me bring it up. R, exactly. R is the letter that we are using here. So I will highlight this 8% in purple. Let's keep going. Use an exponential function to find the number of student athletes after 5 years. So what's this 5? Hmm? T, exactly. This 5 is going to be T. So we figured out the 3 things that we needed to find to apply the exponential growth function. That's how you will do it. I will just write down the function. I will not solve it for you. You should be able to do that yourself. Let's see. 300. And if you want to understand it again yourself on your own, use a video and work on that. Okay. Thank you. I'm writing now the function over here 8 divided by 100 all raised to power of 5. That's how you will do it. Let me stop the recording first now. Got it.